Hi, in this video we're gonna look at how to do derivatives using MATLAB. So let's say we're interested in finding the derivative of a function like this. We have a long polynomial, and this is the first way of finding derivatives. But this way we only find derivatives of polynomials only, unless we do it symbolically. So to find a derivative of such a function or polynomial, let's do that. So we would create a vector that we're going to call it y, and this equals something. We're going to enter the coefficients in front of the powers of x. So it would be -5, 0.8, and it looks like 2 and -14. 2, -14, and 0.8. Yeah. All right. And here we use the polyder function. So we say dy equals polyder, and this would be y. All right. So if we run this, this gives us the derivatives. All right. So to create the vector for a function like this, for a polynomial, I forgot about the 0 at the end. So we started with -5, coefficient of x to the fourth. So we should have 5 numbers. It goes all the way to 0, to the constant number, which would in this case be 0, because we don't have it here. We have -14x. And when we run this, we get the derivative. This is the derivative here. So it'll be the coefficients in front of x cubed all the way to a constant number, -14. All right. The next way to do this is to do it symbolically. So to do that, I'm gonna comment here, and so let's do it symbolically. We say syms xy, just in case, to be sure. In this case, we have y equals. Let's just copy and paste this and fix it up. So we can. So in MATLAB, we have to enter multiplication symbols. We can't just say 0.8x cubed. It needs to be 0.8 times something. So, but notice that we don't need to do it element by element because I'm in symbolic mode. So what we do is we say dy equals diff y. And when we run this, it's the same as what we had before for the for doing it with vectors and the polyder function. But with this one, we don't have to always have polynomials. We can take derivatives of any function. So let's take the derivative of a function that is not a polynomial. So we can say y equals x times e, so it will be exp, and we put -4 times x plus 2, like this, and we take the derivative of this function, and we still get a good answer. That we were still able to take the derivative of it. So this is the derivative of this function here. And next we can also take derivatives, partial derivatives. So let's do that. So we can say z equals -5 x squared times y plus 6y. So times y plus 6 times y. And we can take we can first do dzx. So this would be derivative of z with respect to x, and this would be z comma x. And let's see what we get. So it gets -10xy, and we can do the same for dzy. We say dzy equals diff zy, and this is with respect to y. This is the answer. All right, and this is it. This is basically all you need to know for taking derivatives of functions. So there are two ways: symbolically and non-symbolically.